but so the probability to find me in a bar coding near to you is right bigger than finding me in Munich these days. I studied electronic engineering and specialized in the direction of system ergonomics. And yeah, I'm concerned how we can make programming easier for humans. Does somebody have problems understanding me like that, or is the acoustics good like that? Volume a bit higher. Okay, I can try that myself. So, so much about me. Well, as I'm running around with one of those ridiculous shirts, it's a Plone logo. I have a strong background with the Plone community. I started as a freelancer 3 years ago after being rather disappointed by the university system. And yeah, so now I'm a happy programmer and Plone background. So let's have a look what I'm going to talk about. But wait, I learned with Occupy that whenever you want to say something, you're going to first ask yourself the question, why am I talking? But there's some nice flowchart. I'm going for my own reasons. I needed to structure my thoughts, and it's a perfect opportunity to give a talk if you need to structure your thoughts. It was quite successful. I just finished in time to structure them. Thank you very much for having me here. It was already now a big step further in the project. So I think I have an awesome idea. I want to present that, and I need your feedback on it, because the Python IRC channel tried to block the most stupid parts of the idea, but probably there's still some in there, and it's your task to take care of that. In order to assess what kind of idea I have, I mean, you need to understand what I'm talking about. So I don't want to lose you on the way, but I also don't want to bore you on the way. So let's try. If I'm talking and talking and talking, and you're really sure, like, hey, he made his point, I got it, I got it like 5 minutes ago, it's time, like, just move on, Flo, just move on. If I say something cool, if I should go to bed tonight with the happy feeling I have something good, then you snip a little bit. And, well, if I wander off too far into not slide-covered things, just remind me I have slides, which is I can use them. I shouldn't talk too much without the slides. And last but not least, I don't think it's sane if you try to remember on which slide you had a question, and then I try to find that slide in the end again. So just ask right away. I'm going to repeat the question, so we have the question on the recording, and then I will try to answer the question or point to later in the slides when I'm anyway answering it. So if I would have been able to properly control my tools, then this wait thingy would have been before the outline. So now we have a little bit, do it like this. Yeah, I'm going to talk about let's get rid of this pointer here. What is my motivation, why I'm doing all this? Some existing concepts. Then, yeah, scientific questions. I'm not saying this because I want to do woo-hoo. It's more like I try to treat it in a, like, to prove what I'm doing, to analyze, is it really a step further, but you're going to see later. I'm not doing so far. I'm just claiming I'm going to do this at some point. So far I'm just coding. Yeah, well, then one approach, I call it aspects, more on that later. Another approach, dictionary and aspects, and what conclusions I have so far, and then there's some real code if you want, or some future ideas, or some arbitrary strong opinions if you just want to crawl about. So I've been here. Motivation. I'm impatient, really impatient. So when I'm searching code, like I want to know where is this done, I'd like to find it in the place it belongs. So whatever is fulfilling one function should be in one place. A very nice side effect of that is that if the code is in one place fulfilling one function, you can always use it if you need that function. If you have code that fulfills two functions, you can only use it if you need two functions. So you split it and you make two functions. So functional cohesion, the more one thing you create, be it an object, a module, or whatever, is concerned with one function, the better you will be able to reuse that code, and the better you will be able to find that code. So that's two driving concepts, and yeah, I'm trying at the moment to drive this to the extreme, like to reuse whatever single part is possible. Going to see more on this later. Actually, we could do this here a little bit shortly. So if we imagine you have a database and you have another database, and this might be SQL, and this is LDAP, and now you have some accessor thingy with which you can retrieve something from there. And on the next level, you tell it, we're going here now already, because this is specific to the database. Now we have something which understands this is users, and the next thing understands, let's make it simple. So next thing is we're going to the command line, and we're going to, for example, PyQt or site. I don't want to take site at the moment, PyQt or PySite, or we have web. Then this is now 3 layers only, but the more layers you put here in between, the more code you will be able to reuse. And currently I'm trying to avoid to use schema libraries or anything like that for rendering web forms, but I'm currently on a PyQt project, and I'm also not using any there. So I'm just trying the minimal approach, what is needed to render a form. And how can I keep this unspecific to whether it's a command line, a PyQt application, or a web application? And only the very last layer where it's HTML or printed nicely formatted to a command line or a Qt widget with a table, that should be the specific thing. Because then I can reuse the whole other thing. And this part has no idea we're talking about users, and this part doesn't know we have SQL or LDAP. It's all layers. And then coming later, that's coming here to dictionary trees. If we limit here to dict APIs, then I think the reusability will grow. So this is motivation. On this point, maybe 2 projects I was helping to work on over the last 1.5 years, which is kind of the predecessors to this, or I consider that, is Plumber and Node. Not Node.js, Node. With add-ons like Node, X, LDAP. And we did there a user management application which is unspecific to Plone or Django or whatever. It's Python, and you have a glue layer which can put it into Django or into Plone or whatever. So 37 minutes means I'm talking since 8 minutes. That's cool. Flipchart Plum. Cool. Existing concepts. On class level, for functional cohesion and code reusage, we have Mixins. See an example in a moment. The idea is I want to have code in 2 class hierarchies, so I put it in neither of them and I can mix it in while inheriting. And on the instance level, a similar concept is called adapters, but they are code-wise incompatible, so we can't use the same thing for doing both. An adapter is taking an instance, whereas a mixin is going into a class. And I'm going to explain a little bit more detail what I think about limiting the API freedom. So a mixin, we have some base class, and we could, for example, do a very, very stupid prefix mixin, which on getItem removes the length of the prefix characters in the beginning, then calls in the method resolution order the next getItem function and returns that. So we can remove the prefix, call the next one, and that's the way how we use it. We create a class mixed, and then it's a prefix and base. Now something similar for an adapter. When the adapter is created, it will get a context. That's for example, a dictionary with 1 key in there with a value 1, and I can specify a prefix. And on getItem, I remove the prefix. I call the next thingy, like the wrapped getItem function in this case, and return that. So it's code-wise basically the same, but because of the difference that we have this context thing here, and in the other case we had the super method, going back one. Here it's a super proxy, which will during runtime walk up the method resolution order, which is a weird zigzag depending on what you're doing. It's not that, whatever, no, forget the weird part. It's called C3 and it works. So it's going up there, and it finds a get item, which to call next. And in the other case, we know we want to have the get item of our context, which we wrap. So both nice concepts. Now it would be cool if we can use one and the same code to do both. About limiting the API freedom, you can do things like that. I made it really bad by including the user here again. So you say users folder, add user user, or list user IDs, or list users. Actually here the user should be included, well maybe, if it's a user and group folder. Delete users, and I think this should be like that. Users ID is users, and user keys is then the IDs, and a key and ID corresponds always. And user values is then the users themselves, and if you want to have the typical tuples of user ID and user, then you use the items. And yeah, well, search users, dictionaries don't have search, so obviously there is a limit. Now it's a question how hard this limit is and whether there are ways around that. Conclusion, we have two nice concepts on class and instance level for functional cohesion and code reusage. They always go hand in hand. If that increases, this one increases. But once we reached here a very, very good maximum, well, yeah, local maxima maybe. So then we want to limit the API. And the idea here is if I once write a caching algorithm or caching thing that knows how to cache access on a dictionary, I will never write this again. If I once write pagination or batching for like I want 10 results at a time, I will write it once and I will never ever write it again, because whenever I need that, I use it on my dictionary. It doesn't even matter whether it's web or some hacked up command line script or whatever, it's still the same code. But yeah, there are limits. I mean, search users, another thing, I mean, you don't do dictionary as matrix multiplication or whatever. So, well, I'm coming from a Plone background, so it's all content-ish, it's all I/O, it's not massive calculations. But once you're doing I/O, I believe this is always possible. But yeah, it's part of what I'm trying to find out. So, questions? Can the same code be used to realize the functionality of mixins and adapters? And what are the pros and cons of limiting yourself to dictionary APIs? In contrast to arbitrary ones, where are the limits? Now, I believe I found an answer to the first one with aspects. And you say now, like, why, what aspects? There are scary aspect things out there which function in a way that you create an aspect and then you tell it in which classes to monkey patch itself, and it's going to change that. It might make sense for security implementations where you want to make sure every class I have somewhere is getting this access control management. But in general, I don't like things that change. What I'm talking about is purely functional, and I know what purely functional is because I read a book about Haskell. I understood half of it, maybe 1/3, but I understood it's an awesome concept. You once define something, and it's never ever changing again. In Haskell, if you say A equals 1, you cannot say anymore A equals 2, because you already said it's 1. This brings a lot of problems with it, which I didn't understand yet, but that's the other part. So we're talking here about white magic. It's a meta class for greater good. We're talking about the sacred cow of metaprogramming, which means like it's all you ever want to know about metaprogramming. I think the Python documentation says about meta classes, you don't need to know what they are doing, except if you know you need one. And if you use meta cow aspects, it's even less likely that you will ever touch a meta class manually. About the name, I think it best fits the concept, but I'm open for a better one. So everything that deals with the aspect of prefixing is in the prefix aspect. I think it's natural language in action. Aspect instead of mixin and adapter, we need another diagram shortly. So what we actually want to achieve is we have a class, and now we can mix in on the way over there, and we get a whatever enhanced class, and then we can go down here and we instantiate. And we get the enhanced instance. or we first instantiate and we have here a normal instance, and on this way we adapt. And code-wise, this would look like aspect, which plays the whole role in the whole thing. So over here we would say enhanced class equals aspect of class. Likewise, below here we would say, well, those capital letters are not really sane, so we have here the enhanced instance equals aspect of instance. That's where we want to get, and that's where the meta class is coming in, because next slide. So aspect should behave as a mix-in this way. What are mixins able to do? We can override stuff in the class that exists already, where we're mixing in. We can do supercalls to traverse up in the method resolution order, and we can provide default values. If you put the mixin on the other side, its values will only be taken. Code examples to come. Mixin. Base class has an f. Mixin overrides the f. Mixin is used calling f 3, not 2. Same for an aspect. Looks completely identical. Only difference, we're not mixing it in, but we're using the aspect as a decorator. And now if you look at that, aspect is a class, because it should look as similar as this one. But normally now this class would be instantiated, and it gets the class C, which is not what we want. So there's a meta class which is catching that call and implements the whole white magic on call of aspect. And we get the same effect in both cases. So what about supercalls? I mean, we just were here. Here we override, but we have super to get up. And here we're not in the method resolution order. Just a side note, an aspect is an abstract, if you know what it is, it's an abstract base class. So actually the class C is going to be a subclass of the aspect. But aspect is not in the method resolution order. So we're not finding its methods by normal Python means, but we're building something else to get there. So the method resolution order is using that super proxy, which is upon execution, looking, is there a function called f somewhere in my method resolution order. With aspects, it's a pipeline, and I use a special decorator called plump, well, because you plump together the different parts of the pipeline, and you're going to get a next function, which is the next in the pipeline. And it's part of the meta class's job to figure out what is that. So in our case, we would get here the, because we plump now, we would, whenever we apply this now here on this class, and if that class has a class called f, then we will get it. If this class doesn't have an f, we will get an exception during definition time, because it will tell you there's a pipeline which is broken. We want to plump something, but it's not there. Now we can in both cases pre-process something. We call the next one, and it's pre-bound to self. So we don't need to pass that, and we can then do something afterwards. So that's the pipeline, going in one way, calling into the end, and going back way. And pipeline becomes more obvious if you plug now together 10 aspects, because as a side effect, we pass here, not a side effect, sorry, as a massive feature, you can pass a class to an aspect, you can pass an instance to an aspect, you can pass an aspect to an aspect, and you get a composition. So you can plump your pipelines before you're actually using them, before you put them on some class. Yes? So the question is that why we need a pipeline and only one call would be enough, or? But which call? I mean, we're having in this one we only do one call, calling the next. And that could be a huge pipeline or a pipeline consisting of two parts, a beginning and an end. Okay? So there was the super calls. Now we want to provide something as a default value, which in case of a mixin, we do by putting it on the end. So A is 1 because it's coming from up there. Mixin is not overwriting it. B and C is coming from the mixin, but C is overwritten by this one here. So this is, yeah, mixin is only providing default values at the moment. To achieve the same with an aspect, you need to decorate your values. That's the point where this plump and this default, it's actually classes again, but implementation detail doesn't matter at the moment. Point is, in this aspect, there is something called A, and it's going to have a value 2 with a priority of default. Normally the priority is override, in this case it's default. You could invent arbitrary priorities and make a very fine-grained control. So far I think it's only 2 needed, might be more at some point. In Plumber and Node we had 4. I didn't use them so far, so I'm trying at the moment without them and maybe put them in again. Which also meant the code base is currently about 200 lines of code implementing the whole thing. So it's getting very slim right now. Now we apply the aspect, and here's a big difference. The class is created with the C equals 3, and then the aspect is applied. Important to know, because here the mixin is put in, and then the class is overwriting something in the mixin, whereas in this case, you build one class, and then you apply and pass it to the aspect, and it gives you back a new class, which will end up in the same. Okay, default. So conclusion, we can override, we can default. We can, of course, if we leave out here a default, we can have a combination of that, which is way cooler than in Mixins. Ask me later about our application. I don't want to miss other important things, but there is cool applications for that. Instead of the super call, we do the next call, and we have verification of the pipelines during definition, not only during execution. So we know already if something going wrong when we create all the classes. So this is awesome. Nobody snipped so far. This is really frustrating here. Now, aspect as an adapter. We want to wrap instance methods. We want to access instance state. We want to keep adapter state. And we want to keep, or ideally change instance state. Have a detailed look at that. Adapter is taking the context in. And what are we doing here? Wrapping an instance method. You have seen before, same concept. We do preprocessing, self-context F, multiplied with an aspect. It nearly looks the same, except we don't need to take care of this. Because the meta class made sure that this next is, we're down here. What we see in here, there is a self in the adapter that is this one. That's the adapted one. There is a context, which is this one. And here in the aspect, there is a self, which is this one. And there is next, which is magically, I'd call that not white magic anymore, but maybe gray magic. This is magically bound to this instance. So if you call it, you have a function in your hand which is working on that instance's data. Like a dictionary. If you prefix here on the way, it's going to be the value from here, but because it's bound here, but you actually have a function over there, and that's where you can get the prefix from. Instance versus aspect state. I'm currently trying with this way. So we have a get attribute fallback, which means we have a class, we apply an aspect, we put an A on the instance, and we have the adapted or the aspectified instance, and the A is also here. So if A doesn't have something, it's falling back onto instance. And we have set attr on the aspect instance. So we do here the A equals 1 again. We put a 2 on the aspect instance and the 2 in the B. The A is now here too, but on the instance it's still 1. So it differs now. And there is no B on instance. And if you look at that, yep, that's prototyping. So what we have is prototyping in Python, which I at least expect a flame war about, but I don't see another way to achieve the combination of an aspect and an adapter. Bullshit. To achieve the mix-in and adapter fusion, we need a way to deal with the same code about it, and currently it feels it's the prototyping which is doing that. So we have gray magic for doing the wrapping functions. There is an ad hoc class created from the old instance, except blacklisted functions. there's bound methods be taken, put on that class, and then this ad hoc class is instantiated, which means all the new methods of the aspect instance are already bound to the old instance, so they won't receive the self. For more in-depth reading, that's descriptors doing the magic there, and the moment a bound method is not a descriptor anymore, so it will not be bound again. It's bound already. I might have said something wrong right now, but from the result it's the same thing. But we still have the problem we cannot change instance state, and we need a way around that. That's where the dictionary trees provide a solution. So aspect is independent of dictionary trees. You can do whatever you want with that. Maybe you can shoot at NumPy with it. I actually have a NumPy project at the moment. I'm going to try at some point, but I don't see it at the moment. I'm mentally stuck in dictionary trees, and this is the hammer at the moment. I'm going to hit everything with it until it's clear this doesn't work. It's like cooking eggs with it or whatever. But now dictionary trees, that's drawing again, and simple concept. You have a root node. Let's put it in here. But it doesn't matter how it's named. Then you have another node, for example, that's A, and we have a B. And then we have another node, and one more. And that's let's call it A1 and A2. Let's make it arrows. It's a directed relation. So this relation here is we have the parent and the child. The ID on this side corresponds to the name on this side, ID or key. If you know the SOAP iLocation interface, it's basically that with the, if you like it or not, I use it at the moment. I thought it's the sanest approach. You have a parent pointer and the name, and once you store something in a dictionary, you set the key as the name, and you set, like storing A in root, will set A as the name, and will set root as the parent of that. So if you're down here somewhere, you can traverse upwards, and you know who you are and who's owning you and stuff like that. But this is not, this adopting behavior is not needed for dictionary trees in general. And now, what is that, parent-child relationship? Attributes dictionary. So we now had the problem that if we adapt one of these things here, we'll use different colors, huh? Maybe later. So I adapt one of these, and now we have the problem that, yes, I can get all this state, I can get over onto my new thing via getAttre, but if I do setAttre, I always end up here, which is stupid if I actually wanted to change some attributes over here so the rest of the code can see it. I don't want, it's not internal aspect state, like keeping track of how often was the aspect used and whenever not anymore. I want to for example, I change something via the aspect and I want to set the modification time on this thing. So it needs to be actually stored on the old instance. Well, if getAttre falls back onto the prototype of the aspect-defined instance, then let's put there something which we can then put our state in. And that is where the, just have here a dot address, and that's a simple dictionary. And you do a getAttre here on address, you will get the attributes dictionary from the old one, and now you can make changes to it. It's the same dictionary. So it's just one layer of abstraction, and you solve the problem of keeping state. So the rule is setAttre, like the Python setAttre function, is always putting aspect state. Let's make that an aspect, so I'm not all the time pointing into the void. So this is our aspect instance, which is using this here prototype. And it will fetch the address, and then we can put something in. And if it's on the other hand, let's also give this here a name. This is inst. And here we have the, let's do it dot address. This will be found via getAttre, but if I'm doing, so I can put stuff in here, dot address, well this, yeah, let's make it like that. whatever, a equals 1. And if I'm doing dot x, y, z, then it would just be here. Could, of course, have one underscore, and you could, I'm experimenting with that at the moment, how it feels, have two underscores, so you actually have the aspect name in the attribute name put on this. But yeah, not sure yet about that. So that would be the dictionary tree, 50 minutes. Questions so far? Yes. Yes. So the question is, why do I forcefully try to use one and the very same for instances and classes? To give it a try, to actually understand what's happening if you do that. And I see an like if I have code which knows how to prefix a dictionary, why should I need to rewrite that thing if I have now an instance in the hand? An application would be just let me see what is coming here more. Search results. So application would be the you have a users folder, you have a groups folder. There's users coming out, there's groups coming out. They can have the same name, but as they're in different folders or different dictionaries, it's not a problem. Now you implement caching mechanisms on this and so on. So you want everything to go through those folders if it deals with users and groups. And now you have groups which their children should be the members, namely users and groups. So you need to prefix the groups, otherwise they will collide with the names of the users. And for that, you already have an instance of a dictionary, and you want this prefixed and then be used by the groups. I think this is I didn't code it yet, but it's as the idea, it's currently there. But I'm happy to realize at some point, this is stupid. Don't do it, because something. So that's the idea of the dictionary tree. And now we can look, we had the problem with the search results before. Well, what we can do is we create a filter aspect, which we see a bit of magic here now. Now the stick is way cooler than the mouse pointer. I could have used the mouse all along. Okay. So there some magic. Yeah, we will see more about that. We define criteria to be configuration of an aspect. And then we can do things like we have a dictionary, we apply the aspect, and we pass it criteria. And then we can use those criteria in the keys method and values method. But the idea is we're not searching in a dictionary, but we are creating a view on the old dictionary in which we then can search. It might be another application of, I mean, if you write all that code for filtering, and now you would need to write it differently if you want to mix it into a class. But if you have there any links, I did I don't know, one-day research on what aspect stuff is out there with the point cuts. I liked it further that if you have decorators, and then you get the next function, because you can do stuff, you call next, and you do stuff. This is way more beautiful, I think, than having one function being decorated as before, blah, 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 do this, and after this, do that. It's getting more readable, in my opinion. But so that was the search result. Conclusion so far. It seems, at least so far, we can use aspects as adapters and mixins. Aspects help limiting to dictionary APIs in case of the search results. So we can create another context, and in that context, the dictionary API has a new meaning. Namely, give me all the elements of the filtered tree, not anymore of the old tree. And we get increased functional cohesion in the way that now the mixins and the adapters also are together, and code usage increases, which is again awesome. So, yeah, we have 10 minutes left. We can look at some aspect implementations to see how this is done. Actually, 10 minutes. More questions at this point, or should we have a look at something? Let's have first a just a short rough thingy, this config thing. A is an aspect, C is a class, and this aspect accepts a keyword, a configuration called keyword. You can call the aspect, which pre-configures it, and then you apply it on the class, and then you instantiate. It's the same as if you apply the original aspect onto a class, pass it the config, and instantiate. And it's the same as if you apply the aspect onto the class, and then instantiate and pass it the config. And you can apply the aspect onto an instance and configure at the same time. In all these cases, is it 4? Yeah, 4 cases. Keyword is ending up on a.config. It works currently. It's implemented in a stupid way. It takes too much code. I'm working at the moment that this config is actually another aspect again, or aspect factory. It's a work in progress, but this works. This is like this stupid that whenever you pass a prefix, you need to define underscore prefix, and in your init method you have prefix equals default value equals none, and then you write in your init if prefix is not none, then really override my old default value and stuff like that. This is all handled by defining configuration of things. Registration of aspects as SOAP adapters and utilities is a cool topic. Should be easy. Aspects as multi-adapters is just need to see whether Rule is in the crowd. Because if I say challenging, he's going to smack me. No, cool. So it's challenging to write this, or actually to think about multi-adapters. Plug application drawing. This one. I drawed it already, so we can talk about that. If you have all these small single aspects down to filter something and stuff like that, then you can, and now you have some visualization of that. Then you can say, okay, whenever something is coming through this in that direction, put a breakpoint in there. Whenever something is coming back, put a breakpoint in there, or put a breakpoint in here if it's get item. Like you end up with data flow programming. Dictree Qt exists already, but in a rough state. Dictree command line interface would be something. Dexterity integration for Plone would be awesome. I saw Kiwi now the 3rd time. I never looked at it in detail. It looks way more awesome than Qt. Don't touch Qt. It might be good, but 15 years ago. Dictree LDAP. There's Node-X LDAP. Should be easy to transport the ideas and make it purely functional. SQL the same. Future ideas. Real code. I'd say 7 minutes. It was quick. Now this. Going here. And no, not that one. Tree. Source tree. Look at aspects. We were talking before about this adoption behavior. So, if we want our other way around. If we want the dictionary to adopt the children, what do we need? Let's start with a set item. We're getting a key and the value. That would be the normal one, the self, and now here's our white magic next, sometimes gray. If the value already has a parent, then we're going to raise a value error because it has already a parent, and we would first need to tell the other one that it's now being moved or something. We save the old name, we set the new name, we set ourselves as the parent. Now we try to call the next one. If that fails, we're setting the name back to the old name. We're setting parent to none again, and we're going to raise the very same exception. Means try to add this thing. If everything goes well, it will be adopted. If something fails, the name and parent is set to the old values, and some other code can deal with the fact whether you want to catch this exception or not. This is it's irrelevant if you want to catch at this point, because here we're just dealing with adoption. And if it fails, we need to undo it. And the other thing is, if we delete an item, we set the parent to none, and then call the next one. And yes, there is a mistake in here. This should be catched, of course. If the delete fails, then we need to set the parent again to self, because obviously it wasn't deleted. By having it like that, whenever you need something that adopts something on set item, you use that. Doesn't matter in what situation. It's once coded, it's write unit tests for that, and that's it. Done. 4. Yeah, we have 4 minutes left. I'd rather go to questions then before showing you more code. I can show more, but yes, please.
Just a moment from this side.
Ah, sorry, didn't see you.
Hi, in the past I've done Zoplane stuff. I was just wondering if, so basically the idea you come up with is to have a clean single way of doing things rather than the two other paradigms of mixins and interface adapters, where obviously Zope has the interface adapters applied above the language level with XML and things. And from experience, I can say it's quite painful having these two paradigms to work with in some cases. But I guess the concern would be that by adding a third paradigm, if the other two don't go away, you're going to make it even more of a problem. So wouldn't it be better to use it only in cases where you were starting from scratch with a new code base and that you weren't as an aspect-orientated project, and then maybe it wouldn't be so scary for people to think, oh no, we might have three ways of doing it.
Yeah, definitely. I mean, the time that aspects enter the clone core, I don't think it's going to happen. This is currently. I consider it a research project. I have smaller projects. I'm using it in there. It's all from scratch projects, and I want to see how it feels. Maybe an idea could also be you write an aspect, and this aspect actually generates code for an adapter, which is using self-context, and is generating the other one, or having it the other way around. Spontaneous idea, I don't know what it's. I don't want to code it twice. Let's put it that way. And yeah.
One of the limitations of this next parameter compared to super is that the sort of wrapped function has to have the same name and signature. Do you have any idea of how you can solve that, or whether it's actually not necessary to solve it at all?
Actually, it is necessary. I think I'm very happy that I managed to transport that much that you reached exactly the same question as I had like a week ago or something. And this works, let me see, next all. So my current solution to the problem is, make this a bit bigger. It looks like that. On next, that's not a function. Actually, it is a function. It's not the original one. It's once wrapped, because on bound methods and built-in stuff, you can't put attributes. But I put there on all class, which upon first touching it will be instantiated, and then has all the other methods of the next layer in the pipeline. Which leads to different behavior, which you see there are commented things at the moment, which I'm currently, I don't know how to solve it. It's one limit I'm currently hitting with the approach.
All the stuff reminds a bit of some other languages that are even more dynamic than Python, for example, Lisp, Clos, or things like that, or XOTickle that does similar aspect things. Did you measure any performance for this yet, so you know how much slower it is? I know for XOTickle that some of those methods and lookup and mix-in things did slow it down quite a bit, until the developers added extra bytecodes to resolve that.
No, I didn't do any real performance measuring yet. I thought about it. Let's put it that way. If you compare, I mean, the only thing where it differs, like I'm creating classes. Like let's not talk about the adapters for a moment, but we're talking about classes. If you create class hierarchies, and if you just override stuff, yeah, well, there is not much difference in going up the MRO. If you start with supercalls, it might get trickier. And I'm avoiding supercalls by creating closures, nested closures, as the pipeline. And that function is sitting on the new object already. So I don't need to search when I'm calling what to call next. But within an aspect layer would mean I have some base class. I start applying an aspect, I apply more aspects, and in the end I subclass again from that. You can do that. It's complete. It will be one nested a pipeline consisting of nested closures put into the MRO of a bigger hierarchy or whatever. But a user of a class that uses aspects doesn't know that it's aspects. And I claim it's faster, but the performance measurements I didn't do yet because I'm not done yet. I'm currently it was based on the Plumber code, and I'm now factor 10, I think, of the code because Plumber wasn't purely functional, but changed things in place, and we need a lot of thinking how to do that. And it's currently reducing, and I'm trying to kick out everything not really needed, and then I do performance analysis and start adding things that are really missing.
Anybody else? Okay, then.
Now the time for the QA starts. Cool, then we can have more code. Or
you were really quick.
I mean, if you want to leave, you feel free to. But if you want, I can. What kind of? I mean, we can have a look at the implementation of a. Actually, we could have a look at a software using that, or maybe more fun.
I have a question, actually.
Yes.
Usually the purpose of aspect is to encapsulate a cross-cutting concern in an application. So I have not seen from your examples which is the cross-cutting concern in this case. I mean, this is a classical idea of aspect-oriented programming. You've got a cross-cutting concern, so something that you should usually scatter over many classes, and then you've got a way to apply this kind of concern to everything. In Python, you can apply this kind of concept using metaclasses. I do not understand from your examples a real use case where you use the aspects in such a way.
Well, about the comparison to metaclasses, aspect use a metaclass for achieving it. And
what more? So what they do that metaclasses can't do, on why are they cleaner to use? I could not understand this.
Well, metaclass, you have this freedom. Aspect limits that freedom. You can't do anything, not everything you can do with a metaclass. Metaclass, shortly, you can, okay, let's look at this code. There's metaclass underscore aspect. Here we have the aspect meta. Aspect meta defines a call method and does stuff. And currently it also defines an init method and does stuff. If you define the aspect, this init is called and you can do things. What does it mean that I wrote there class, blah, 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 and so on. And in the call method, you define what does it mean if I now call the aspect. And by putting things in there, I limit the solution space of what you can do with metaclasses by you can define things in there, and you have decorators of giving it, I call it instructions. If we look at an aspect, that was the presentation over here. If we look here at an aspect, this is for me an instruction. It ends up in the aspect dictionary as an instruction to check for a function f on whatever is there and create a pipeline with that endpoint of the other one and this function. So this is an explicit instruction with Plumb. We had before that here, that's an implicit instruction with override. And we had the default, which is explicit again. Here we have explicit instruction of default. And so it's something like a Swiss Army knife for creating classes, but not like I don't know, it's not a truck or whatever. Like stupid compare. Could somebody tell me I made my point, please?
Oh, no problem. Maybe I take a look at it. This reminds me because of the names, it reminds me to another project written in Python, which is called the Aspect PI.
I looked at that, yeah.
Yeah, and it's more like the classical aspect-oriented programming, but it misses a way to apply all the aspects to a certain category of methods or classes. So I was taking
Here you have the, I mean,
you have to do it explicitly. You cannot define them from a central point of view. You cannot say every method that is called something
that's
gets
what
a certain expect.
That's what I concluded is no scary monkey patching all over. It's we have things doing that. I'm explicitly not touching existing classes. If you want to do something like that, then you could during the whole import time. Actually what you're going to do is you patch import, and you take the classes being created during import, run them through the aspect, and then use that one. So
I was interested because it's not very clean to do that in Python because of the import mechanism. That was my question. Okay.
I would go for import, but I didn't do it yet.
Okay. So
4 more minutes.
Any more questions? Otherwise, we can just let you loose at the coffee break, and then we'll see later for the.
Well, I would have the one example application, which is the Qt thing, which is probably not running at the moment. But anyway, I can show the code. Console script. So I find things like that's actually a fancy one. Make this bigger. Good. That's right. Start further down. The whole application in the end looks something like that. Well, you have a lot of aspects around, and you just plug in your application. Let's see how we do this in 3 minutes. Capital letters is nodes, and so we have aspects applied onto a basic node creates a widget node. Let's stop this, how this is programmed, and go to the dictionary Qt. Source dictionary Qt aspects. One is too big, we're leaving that out. To say there is a basic aspect called Qt, and then there is a specialized aspect which use specific Qt classes. And the moment you apply them onto nodes, they're going to start treating those nodes not just like a dictionary tree, but you can have, for example, down here, a table. So if you have a node of arbitrary dictionary, doesn't matter, and you apply this table thing, it's going to render a Qt table. And it's going to look at the first level is the rows, and then on each row the attributes is the cells. And you can always use this Qt aspect, table aspect, in order to render a table from a dictionary tree. There is another aspect in there, just talking about it now shortly, where you load a CSV file into a tree. Or you load, what's this picture here? It doesn't matter where you end up. I really want to make the units small enough, which are working in there, that you can always reuse them, unspecific to your use case. Okay.
Okay. Thank you very much, Florian.
So much. Somebody needs my email address again, and the links I think are on the talk page to the code. So this is, otherwise I will put it there.
So thanks for that. I mean, one question I have is, you know, with the point cuts and join points and that kind of stuff, is it the implementation of monkey patch, or are you just worried